Good morning, Maurizio.
Good morning, Andrea. How are you?
Good. What about you?
Fine. We have a lot of spectators already
Yeah,
with us.
connecting. Yeah.
Yeah, yeah.
As Tino says, there is always a fan group. Let's say the good names are always participating. Thank you all of you that you are participating. A lot of people are connecting. So thank you for also for the people maybe are in Far East area and they are, let's say, taking time out of their working time for this webinar. Yeah, few information before we start. We can use your Q&A button for making questions, for asking something to us. Not really tapes. Be polite with us because we are, let's say, not, let's say, technical people, not R&D people. So we are, say, we have experience in the market, so we try to share our experience with you.
We try to do our best as usual.
Yeah, as always. And then this webinar will be recorded. You will get also later on the link for this webinar for the other. You can also, of course, get a certification out of that if you participate at least 70% of the time. I think that's all. We can start.
We can start. Yeah, why not?
Okay, let me share the presentation and we go through that.
As usual, we have the first, the first slides are about our company. And so here we have just few details about us, Andrea and Maurizio. And obviously we are not so young, so we have experience in more or less the same process automation market, different, and more or less we know a lot of interesting things, and we would like to share these together with you today, just to let you have more details about SIL and what happened about intrinsically safe. Okay, we can go on. Probably people already know that. Just few words about the company. GM International is on the market from a lot of years. Formally founded in 1993 was Elcon Instruments, and later on, after 10 years, the founder founded GM International. We have 100% internal production. That means that we do more or less everything inside our facilities. Is near Milan, based in Monza, not far from the Formula One track. So if you want to come to see the Formula One cars, you can also visit our company. Why not? We are a specialist in intrinsically safe and SIL certified devices. And we more or less follow oil and gas, petrochemical, pharmaceutical, fertilizer, mining, food, and other markets. Obviously, oil and gas is where we focus, but are also increasing our products in other markets. We can proceed also with, okay, where we are. We have 9 direct offices all over the world. We have offices in the United States. Obviously, we have other offices in the United Arab Emirates, Asia, Singapore, India, and so on. We have obviously a lot of distributors that help us because we are in sales, but our sales in GM are not so big. And for this reason, we have a lot of distributors, Europe and all over the world.
We can't hear you, Maurizio, very well.
Sorry? You can't hear me? It's okay, Andrea?
Oh, yeah.
Okay.
Now, yes.
So, okay. We have 200 people in our staff. So we are based all over the world. So most of these people obviously is in our factory, and the rest is in the other offices. We do more or less 20 training courses about SIL, about SIL certification. We have one guy able to do the SIL certification. After this training, that is usually 3 days plus another half day to do the test, the final test, in order to receive the SIL certification. And the people that is able to do this training will be able also to have the SIL engineer certification. I'm not able to see the presentation now. Okay. Again to see, perfect. And we have obviously thousands of installation everywhere in the world. We will let you have finally some more detailed information. So what we are doing, we are working in order to have safety first of all. That means that SIL products are always present in our catalog. We obviously try to have all the certification necessary. We test all our products, so 100% of the products are certified internally in our factory. This means that we are perfectly sure that when the product is leaving our factory, is working properly. There is not a presentation, Andrea, in this moment. Can you see the PPT?
I have some problem with the connection. Let me try with another network because
okay.
sorry all of you because of this, but let me see if I can connect to another network.
Yeah. And we can proceed anyway. So we have all the products completely done in our factory, and we try to have, as I was told you before, all kind of certification. So we try to have the certification necessary for the market, so intrinsically safe, the IECX, obviously the ATEX certification, also for the marine and naval market. So we try to have every of these certification. For this reason, we give also the 5 years of warranty. So we are trying to do everything to guarantee to the customer a very good product, safety, SIL. So what is necessary to have the plant from the safe side. We can go on, Andrea, with the other slide. This is our production. Obviously, probably you know very well GM for the first two, probably 3 products that are IS barriers, safety relay, and isolators. That means that are barriers, but without the certification for intrinsically safe. But it's important to know that we have power supplies that are SIL 3 certified, multiplexer, that means they are able to receive digital and temperature signals from the field. We have the termination board to connect our barriers to the DCS supplier. So we have the possibility to have the connector for the flat cable of the main constructor, Honeywell, ABB, Schneider, obviously Yokogawa, and so on. We have the HART multiplexer when someone wants to have the HART signal superimposed on the 420 milliamps divided from it for diagnostic or for communication. We have also the surge protector. In Italy, unfortunately, we have a lot of storm, so it's not necessary, but strongly recommended to have one of these that allows us to protect the 420 milliamps, the signal. And we have the new series. The X1 is the new series launched just a few months ago. And we will probably speak in another slides, another presentation. And again, we do this type of training and courses and services about SIL and X. This is included in one slide only, all our customers. So you can see we sell our products to a wide range of customers, system vendors, EPC, OEM, and user. You can see a lot of very well-known names, and more or less all over the world, starting obviously from Italy and then Europe and all over the world. Now we arrive at the first question. How important is SIL certification in hazardous area application?
If you want to share this poll, Maurizio.
I will share the first one. And we can see from your side, please let us know if SIL certification is so important.
Yeah, this presentation regards, of course, is based on SIL certification and mixed with hazardous area. So sometimes required, sometimes not. We want to have from you more, feedback if it's really required or not. I see, Maurizio, that people are really asking for that. Really asking for that.
This, most of the people, is asking to have.
We can stop, and I think now because most of people already voted and they share the results, so people can see.
We can share the results. So these are the results. So 58% very important, plus 6, we arrive to 64, and 90% of the people, is saying that is important or more. So, okay, we are interested to this presentation.
Okay, great. We can stop it, sir, and then now I will take over the presentation from Maurizio. Thank you.
Thank you.
Sorry for this trouble with the network. I hope that I solve all problems. Maybe Maurizio, you can advise me in case having that. Okay, so safety relay application. Of course, it's very important to know the probability of failure on demand, or PFH, indicate the possibility that a device, a SIS, is not able to carry out the required safety function. This, of course, is something that is translated into SIL. So if you are not able, or you are very, let's say, capable to carry out the safety function, you get a better level of SIL. And of course, in our market specifically is situation is very simple, where you have to open, close something, a valve, a motor, start, a stop. So and basically a device is a SIL rated when is able to support and let's say perform the required function. So you see let's say a scheme there, where you start from the sensor up to the actuator, the valve, where you have different devices, and of course the probability failure on demand is the addition of the different probability failure on demand of different systems of the sensors to be SIL, the barriers, in this case the isolator and the PLC, the logic solver, the relay, the actuator, and the valve. Everything has to be considered to get a SIL level in your system. So safety relay for any critical application. Of course, and when is required to be used in the SIF, it must be confirmed adhere to IC 61508. Typical cases of application is when a controller is not able to deliver the required power, so in terms of voltage or current, because sometimes, most of the times, all the DO card, PLC DO card have a limited current capability, so you need an external relay for increasing this power. Okay, or when you need a multiplicator in the number of contacts, so you want to have one DO from your PLC and multiple output on your system. Or maybe you want to invert the safety function. So you want to close the contact and maybe open the load, or the other way around. So there are different situations. We see also maybe for line monitoring, there is maybe a point which is very important. Maybe your PLC is not able to monitor the load, so you need something, a safety relay that with additional functionality we'll see later. So, and the safety relays is not only used in oil and gas, where we are working, or petrochemical industry, where we are very focused, but other industries that can be railways, very important. So you need a high level of safety, cars and lift, power distribution, and any other application, also environment application, where the safety is highly recommended. So SIL certified relay, so a standard relay cannot be used in a SIF. So if you have a SIF, safety instrumenting function, where SIL is required, you cannot use a standard relay. Otherwise, you go to zero. You are not anymore safe. So a SIL certified relay is a relay with a known and warranty ability to perform a given safety function. So you know with a certain, with accurate value, what is the percentage, what is the probability that this relay is able to perform the safety function. So, and the safety function is the capability, as we said, to reach a safe state on demand. Open a relief valve, actuate fire extinguish system, for instance. Okay, can be ESD, can be energized to safety. So safety function normally is normally energized, so you need to de-energize to safety. That is DTS. Of course, the other application, fire and gas, we need to energize in case of safety. So in both application, the safety lay is required, because you are in a critical and very important application where not a yes is required. Okay, so maybe it's not hazardous area, maybe yes. Okay, but the important thing is that the relay, or the device, has to respond correctly to a demand. So what make a safety relay? In the safe, there is, of course, every device for every device there is FMED analysis. Okay, so there are different components. Okay, inside, and for each component there is this table that you can see that there are different probability of failures that can be failure safe, dangerous. SD stand for safe, dangerous, safe and undetected. So safe detected, safe undetected, dangerous detected, dangerous undetected. So there are different types, and of course the dangerous undetected failure are the most relevant, the most important to be counted into your safe. So you see, for each component there are different values, and at the end you can get out of that the complete FMED analysis, give you, of course, the parameters and the SIL level of your device, or your relays. If you're using standard relays, this kind of calculation is not required. Okay, it's not necessary. It's not, of course, you don't know if you have if your device maybe is very safe, but maybe not. So you don't have the say the certificate and the calculation that say that you made all this procedure in order to get safe your device. So application by difference between DI relay and DO relay. So there are different relays, both can be safe. Okay. So if you have in the field contact 24 volt, 48, and so up to 230 volt, how you can get into the PLC. Okay. This is the application where you have 24 volt field contact, okay, up to 230, or voltage free contact. You want to isolate it and send to a standard PLC. You can use different devices. Okay, just to give an example, of course, how you can use the relay. Okay, or you want to interface two systems, two PLCs, okay, and two systems. So in this case, you use this device in order to connect and send the contact to another system. So sometimes in a typical application. But we want to give an highlight, a better highlight what, so we talk about SIL, and very important is the diagnostic. So the diagnostic in the systems, for instance, in the smart relays we see in the project we are working on, I would say more than 50% of relays now are required with diagnostic. So why you have to choose a relay with the built-in diagnostic? That is the demand. Why? So because old system, the OCR, do not support a load diagnostic. So the specifically, and let's say all safety system probably, so the OCR do not have the load diagnostic, very much required now. This is the second point, is also related to the fact that the DO card have not are limited in voltage and current, okay? Or maybe they have a diagnostic limit, so extreme loads, earth leakage, they do not have a complete diagnostic. So the smart relay, or the relay with the line monitoring, and the line and load monitoring, make diagnostic available to the system. So they extend the DO diagnostic capability, and they give a real-time alert for any load fault in the both cases of normally energized or non-energized application. So there are different applications for that. So this is, for instance, the solution where you have this solution from us, of course, SIL relay with a 5 amp, normally energized or mid-energized. They give you the short open circuit and voltage detection, both in a load on and a load off. So the point is, when you use a device, in this case a relay isolated the field from the system, because there is a real isolation. And but in this case, you use because you need extra power most of the time, or you need extra functionality. But as long as the device is isolated field from the system, also you don't say you don't you limited your the diagnostic, because maybe your DO card is heavy diagnostic, but you need more power. If you put a relay without diagnostic, you get say you close your diagnostic ends or dies at the relay coil. So, but if you use a smart relay, you can more or less, or maybe you can extend your diagnostic capability. So there are 2 points. So you can have also this functionality like a fault mirroring to the system DO. So on your digital output, you can get directly the fault. So your digital output card will see high impedance that looks like a fault, and your system will detect the fault. So it's something that improve your capability also by using a relay that basically should say die, should stop your line monitoring for the O card. More detail here. So you have, for instance, a situation where you have the load is on, so the power on the valve is, so the coil is energized, and you can get out of that these two parameters, load current and the supply voltage. You can monitor it easily through this diagnostic of the relay, these two parameters. You have also, in case of the DO off, you can monitor these two parameters, still the supply voltage and the load resistance. Okay, this is two parameters. Also, you can get in when the load is off, meaning that in any case, I can get for sure some information from the system if is because most of the time probably you have on your experience, you have field devices that are really far away from in the field. You never know what happens. So you're just closing the relay, opening, but you don't know if you have a real current into the system, you flow in, the valve is okay, and so on. By using the relay with the line monitor, you can get this information immediately in the real time. There are also other relays that give you more details. So you can have this parameter like load voltage, earth leakage, internal coil integrity for the relay, our relays, okay? So, and you can also transmit over fault contact out to fault mirroring, like in previous application, or Modbus. And also the parameters are completely programmable. So this is also used when you have a specific loads. I'm thinking about high inductance loads that maybe can, if you use a standard relays and standard device, maybe you can incur in continuous fault. This one can you can set the parameter that has to be recognized as a real fault. So in this case, you can get with this system, you can get a different, you see, also our relays are not, of course, are good, very safe and so on, but you can get some fault by chance. So this relay give you, beside if you remember in the previous slide, we had the possibility to monitor in the standard monitor relay the supply voltage and the load current, but in this case, you can also monitor the internal coil integrity in this status. If you have in the off status, you can monitor it beside the load voltage, also the resistance of the load and also the earth leakage. So there are multiple capability on this solution. And the software is here, so you can configure, as I said, you can say which voltage level, which current level, which resistance, with the isolation resistance. You can set the parameter you wanna recognize as fault. Okay, so it's very useful in case of specific. I would say it's a universal diagnostic system for all the relays, for all say not some relays, for all values. Okay, so and you can use with different loads that can have also high inductance, high capacity, whatever is very difficult to be monitored. Okay, so just to give you more details about how you can detect this fault, because this is a sort of very the point is I wanna highlight with you is that you have we call about dangerous undetected failures. So dangerous undetected failures are the most complicated and most difficult let's say situation you get in cures. But if you are able to monitoring these parameters, you transform this dangerous undetected into dangerous detected failure, which is still dangerous, but you can detect it. How you can detect it? You can detect in this way. So you have this fault relay. So you get a contact. So I got a fault, transmit this fault contact out, so you can connect to your DI card. Or you have the pass testing. So through the pass testing, the card, I can get this, of course, monitoring, mirroring functionality. So directly on your diode, I can get this high impedance. I can recognize the fault. But there are also on these two relay, there is also, of course, the fault on bus. So I have a bunch of relays. I can get, and this can be connected in parallel, so I can get out of that one single contact for all relay connected. I can have also Modbus, so communication. So in case I want to have more details, because of the contact, fault, and mirroring, just to give you a general information about the fault. But if you want to have more details, what kind of fault you have on your system, the Modbus have all the registers for each fault you get incurred. Okay, so fault mirroring to the PLC, what is that? So is something that I already said. What it specifically is if you get a fault here, this relay, for instance, D5295, but others one, can transmit this fault to your DO. How the DO see this fault will see through an high impedance. So the system DO, it will see high impedance on his output on this contact. So and then the fault will be recognized. What is important in the system? We see that safety is highly recommended, but also availability. So in our device, we have 4 relays connecting in this matrix application where you have 2 relays in parallel and the load and other 2 relays. So this is the off condition. This is the normal condition where you energized. Okay. You energize the load and the current flow, and you can get your load on. So you see that all 4 relays are moving. Okay, but I would say that the safe state is that one. And what happens in case of fault? If the point is that this condition is hardware fault tolerance equal to 1. So I can have one single fault on one relay without compromising the safety function. So my device is safe because it's SIL3, very high with high safety, but also is available because this a single fault on one relay is not compromising the safety function. This is for normal energized and normal de-energized application is valid. This kind of matrix release. So another application for relays, this one for sound and beacons. I'm pretty sure that you meet this application during your, of course, applications, your projects. Sound and beacon control is always challenging. It may happen that the relay goes into fault condition for some instant after the sound has switched off, because there is this problem. So after the sound is switched off, the relay goes into fault condition for some instance. So the sounder has a very high impedance, which the relay detects as fault. So it may happen that if you use a standard relays, and this one is a line monitor, but not configurable, you can get in this problem. So the application that we analyze with our technical support team, so found that one relay here is glued and is no longer able to switch. So this kind of devices, not this one, this brand, but of course the type of device, of course, created say glue this brought the relay to be glued, so is not able to work anymore. Okay, so the capacitive load detected as open circuit cause a high peak of current, causing the relay to fail. So there was this kind of situation, and we solve in this way. So we put this kind of resistors, okay, of 5 ohm in series to the load, okay, to avoid the risk of damaging the relay contact due to inrush current peak. So this inrush current peak was the cause for gluing the relays. And the underlying resistors was put here for avoiding any unwanted fault. So there is a situation where you need you have a relay, but you cannot use for any loads. That is the point. So in some specific case, you have to add some resistors, or you have to use the other relay with but I would say that the resistors for say for inrush current is always required, because in some cases even if you use the configurable relay, this situation you can monitor. Of course, you can avoid maybe the line of resistors here if you use the line monitor relays, but the resistors for reducing the inrush current you still have to use. Other situation where you have bipolar and then unipolar wiring. So this is used, the unipolar wiring is used when you have long distance, you want to use just one cable for connecting the load and go through the ground for the return of current. So great benefit for using the less cables because you have this situation, okay? The bipolar is used in normal situation where you have when the load is completely disconnected, okay? And is suitable only for high voltage load, of course. This is suitable for high voltage load. The unipolar you can use for high voltage loads. And this kind of relays, in case you're using the unipolar wiring, you can grant the diagnostic. So it's the only one that just to give you an idea of examples how to use it, how to apply for specific loads. In this case, unipolar wiring, you want to have a line monitor, you have to use this device because the configuration give you this opportunity. Hope if people are still there, maybe you can launch a poll for
We hope
having
so.
yeah, to prove that they are still there. Sorry. So
So
what safety relay do you use, do you consider as relevant features? So we have seen different features for safety relays, like the pass testing compatibility, the alarm contact out, the Modbus interface, the configurable threshold for specific loads, and the fault mirroring on the O cards. Thank you for answering. People are there, Maurizio. I see.
yeah,
I see
sure.
they're moving.
We see the reply, so people is still
I remind you,
with
if you have
us.
any question, we have a Q and I don't know if they make any question. Did you see, Maurizio?
Just a second. No, for the
No
moment,
question. Okay.
yes, leave to your webinar. We have one question. How is SIL 3 determined in a particular equipment, and what are the basic requirements to be considered during the selection process? Probably a part of the reply was already in the presentation, probably a part.
I didn't get the question. Can you answer? Probably I missed something.
Yeah, is something that usually we do not say when is necessary to have the SIL tree. Is something that the engineering company is doing in a plant. The engineering company verifies how is difficult to keep safety, and in base of this, there is the request for a plant to be SIL 2 or SIL 3 certified. This is how usually is done. There are specific companies doing this. And the selection process is probably already did in the presentation, how we, what are the process while we are able to certify SIL 2 or SIL 3 an instrument, and which is the difference between. But probably we also have another similar request in the question and answer, probably in the last phase of the presentation.
Okay.
Probably we can give also an explanation about one of two out of three. So probably we can give a more detailed explanation
Okay.
in the last part of the presentation.
Okay, yeah, let's go because we terminated this presentation, then we have a Q&A. So IS isolator line monitoring, this is a point also for SIL, so very important. So intrinsically safe isolators, model solution for for connecting sensor in hazardous area like AIO, DIDO, temperature, pulse, vibration, load cell, whatever. So SIL 2 and SIL 3 certification required. And but the point we want to highlight is a line fault detection, because as usual, what is dangerous undetected because you cannot detect it can be transformed if you have a line fault in dangerous detected, so that your SIL level of your system is increased because you can detect what was undetected. Okay, this is the point. So if you have analog input, for instance, we made just a few examples for AIO, DIDO. Okay, so analog input act as the proof of presence of the line. If it is lower than 4 milliamps, the open circuit; higher than 20 milliamps, the short circuit. So Namur compliant transmitter designed to limit their current between 3.8 milliamp and less than 20 milliamp when function properly. So you see, so our the point is that the barriers we are offering, our isolator are fully transparent, so they do not limit at in the 4 to 20, but they have a higher spectrum, so you can transmit these values to your PLC, so you can detect the transmitter has a problem, the fault on your load. For instance, and so we have a solution for analog output. Okay, so the analog output, you can have a short output detection, short, when the load resistance is lower than 50 ohm or 100 ohm. This is you can select by deep switches. The short, the open circuit, when the load resistance is higher than 4.9 ohm at 4 milliamps. So in our device, there is also the fault is reflected to the control system, high impedance, and also there is a contact that you can connect to your DI card. So there is a line monitor in this case. For digital inputs, that is, I see that now in all safety systems they require the DI with line monitorings. So in this case, there is these two lines with this output circuit that transmit different values. So low input state is RA, so there is this resistance. High input states average. So you transform, of course, the contact in input as can be proximity, can be a contact or contact with resistance you can detect. So, but of course, you have to transmit these values to your system. You have this kind of circuit that provide fully line monitoring. For the DO, okay, for the DO is more or less like AO, so you have a load resistance case open circuit that is higher than 10 kilo ohm, and the load resistance in case of short is lower than 50 ohm. So you reflect high impedance to the control device, so you have also this fault output for connecting to your DI card. So that is for barriers, and I want to show you also the solution for you get better SIL level to your plant, which is the power supply. In the power supply, the point is we know that people say I'm using two standard power supplies, redundant, I'm ensuring the safety. But if both are not safe, you cannot get safe your system, because if basically if also you have the beta factor that can affect your application, you can get out of that a really higher probability of safety if the power supplies are not safe. So we have this solution. So with this display with redundancy in the rack on a DIN rail, this possibility, and why you have to use a safety power supply. So the safety system are designed to go to safety by removing power, de-energize to strip or to safety. Hence, the power supply failure will lead to safety. Okay, so all safety functions are de-energized to trip or de-energized to safety. This is not good because there are a lot of applications where you need an energy in case of safety. Okay, you need get energy on case of safety, such in fire and gas system. So not all applications are de-energized to safety. This is the first assumption, very important. So the fail-safe power supply is okay, probably, in the energized to safety application, but energized to safety, the fail-safe, not. So the power supply sometimes can fail in many different ways, low, high, or somewhere in the between. High failure on power supply will lead in the parallel connector go to high causing an unsafe shutdown of the system power them. So if you have two power supply, one fail high, the other redundant, the other will go high as well. Okay, so both are not good, and the power supply can fail in a different way: low, high, high, high. In the switching power supply, you have a circuit inside that from 230 increase to 400 volt the voltage, and then goes to 24 volt out. Okay, but in some cases we experience that this 400 volt went, let's say in case of failure, went direct to the load, and then the case you can burn everything. So there are different, the power supply can fail in different way, okay? Reason for using it. So normal energized load, standard voltage would be in the range 20 to 30 volt. That is the standard, okay, normal energized. So the fault situation will lead the V out to zero, safe failure, okay? The failure is considered dangerous if the voltage out is in the range 2 to 20 or greater than 30. So you can have lower than 20, higher than 30 is dangerous failure. So in the range between 2 and 20, you have an abnormal operation, okay? While if you have more than 30 volt, you can damage, of course, the instrumentation that are connected with. So in the 2 to 20 volt values can be detected and the safety PLC will be alerted, okay? So a SIL power supply reduces as much as possible dangerous failure with the built-in diagnostic. The danger undetected will become dangerous detected. So the diagnostic is important because you can transfer, you can detect these dangerous undetected failures, okay? And yeah, and of course is normally power supply in the market don't have a diagnostic, and you don't get out of that the dangerous undetected failures, okay, information. So also important is the how you connect in parallel, because you have basically Schottky diodes, okay, that are used. You have a external kit that in the middle of two power supplies that arrange the redundancy. We develop special diodes, active ideal diodes that reduce power dissipation, eliminated needs for expensive heat sink or large thermal layout in high power. So these active ideal diodes, of course, is SIL rated, and let's say the probability of failure is very low because the power consumption is very low. Is electronic circuit that much more better than usual Schottky diodes. This is, you see some information that where the active ideal diodes grants better reliability. For instance, heat sink, large and none, the power dissipation at 5 amps is definitely lower. Okay, so this is the point. And the load sharing, of course, the load sharing if you're using a rack with the power supply, load sharing, the circuit is inside. You don't need to wire it, and also the wiring, external wiring, can cause of course, a problem in case say they are not say well structured, and sometimes it can be a problem. Also, this is very important, the short circuit proof. In case of short circuit proof, what happens if you have a load which is short on the out? Basically, the system, the power supply will shut down. We have developed this technology that deliver very high, in case of fault, recognize high peak of current, 800 amps for small duration, 0.5 millisecond, and this granted this instant opening of the protective fuse of the circuit breaker, and this avoid the power supply shutdown. So you may continue, if you have one short on one load, you may continue to, of course, use your power supply without interruption. Okay, so in the meanwhile, I will go with the next presentation with a Q&A, only a few slides. Maurizio, in the meanwhile, there are some...
We have just 10 minutes, so we can see the last slides.
Do we have any question?
No, not new question.
Okay, so we go with the Q&A. Maybe we try to consolidate your question in a few slides you made during your registration. Maurizio, if you want to go through that.
Can you switch to the next slide so I can see the... Okay, this is just to... was the question about if it's possible to install our products in Azzardus location, and the reply is yes. You can install our barriers and the safety relay in zone 2, is allowed. And obviously, as I told you before, we have all the certification just to cover the request. So the standard one is ATEX and ISEX, and then as you can see, we have the Brazilian and the other, obviously for the US and so on, but even for Japan and China and so on, Korea, that are necessary to have the dedicated certification.
Okay, Maurizio, just one point. This is not, of course, an IS application. Is for installation in zone 2, and the load cannot be, of course, the sensor and the valve cannot be, of course, IS, because it's not IS.
Yeah.
Okay, so the next question is...
which are the Azzardus area protection method most used? This is probably we could have a webinar just to this.
Yeah, sure.
We try to reply in very few minutes. There are obviously a lot of different X protection, so it's necessary to see, to verify what is the best one. Even from my previous experience, I used to be an engineer in a contractor following the US market, and with a very big customer like Exxon Mobil. For Exxon, the only one protection methods for EXT. So usually was the most known and the most, from one side, easy to use, because you can put more or less whatever you want inside an EXD housing, and then you can work without particular problem. But obviously, you have to consider that more or less there are some limitation in heating and so on. So it's not 100% true that you can put everything inside an EXD box. And the consequence is very high weight because of the construction that is able to keep inside an explosion. So the way how they are built is heavy, so you have a very high weight product, and it's not so simple to go inside if you have to do any kind of maintaining the instrument and so on, because you have to use particularly cable gland, fixed, glued, and so on. So it's difficult to have this kind of protection. But what we saw also in the past years, that intrinsically safe increased a lot the presence of the market, because is from one side simple to use. You have to do some calculation of the loop, obviously, to guarantee that the power is really low and is between what the rules are asking. But obviously you cannot have the necessity to have a big enclosure to keep all the instrumentation inside, because you have obviously the possibility to use intrinsically safe transmitter starting from the field, and then a barrier based to transfer the signal from the field to the DCS or to the PLC. So it's quite of more simple, and you can access obviously the instrumentation for maintenance and so on in a very easy way. Then we have other protection methods that are the purging EXP. That means that you can use a sort of housing where you can put inside some type of instrumentation, and there is inside this enclosure a sort of very small high gas pressure inside, usually is half bar, and this allows to have the possibility to keep the internal instrumentation safe, because the pressure is higher inside this kind of panel respect to the outside pressure. And also in this case, you have to provide some technical calculation to install this kind of product, but is used in some particular application for air conditioning, heating, or some particular case like the remote instrument building and something like this. And then we have also other type, that is encapsulation, XM, that is allowed for zone 0, again with intrinsically safe, that are only two to be used. Zone 0 is mining and something like this, so very difficult application. And there are also, for some particular devices only, the IXO, that is oil submerged, so something of this. This is in just a few words, because we are closing to...
Thank you. Yeah, indeed. Very few words, because this would require
a lot of time,
new,
really.
Time. Okay, so let me go through pass testing compatibility. What is this? Pass testing, most PLC, safety PLC have this pass testing. The DO card have this continuous testing for the output are generated, can be excluded time to time in some PLCs, but in some cases cannot. So the safety relays, of course, has to be compatible with this, because it's connected to your DO. What happens if your safety relay is not compatible with this? This will activate continuously the relay, that cause a complete, of course, damaging of the relays, and contact shattering, and of course not working properly. So the safety lane needs to be compatible, needs to filter this pass test in order to not activate the output without a real demand from your system. So, and this is basically, can be, of course, indifferent, can be continuous on with off, and continue off with some on, very short. That is used for, of course, for testing your loads. But if you use a relay, of course, everything is isolated, and this is say unnecessary, but it cannot be excluded, as I said, in most of the PLCs. So a SIL3 device can be used in a SIL2 application. The answer is yes, because of course you have a higher level of safety. It is from 1 to, of course, to 4, the level of safety. And but the SIL3 you see in this graph will with the grades by the time. So the probability of failure on demand is higher. So the device can fail with a higher probability by the time. So, and the point is, of course, after a few years, you have to retest again the device for getting, let's say, the same level of SIL you when you bought the device, when you installed the first time. But basically, of course, the SIL 3 device can be used in a SIL 2 application. In this case, if you look at the manual of the product you are buying, you are using, it can be SIL 3 for maybe for 1 year, and it can be also SIL 2 for 10 years. Okay, so the device is much more, let's say, high value device, and it grants, of course, longer safety without testing. Okay. Safety device related design aspects. What are the design aspects? Of course, there are different aspects very important. This one is the architecture, like this case. Okay, so you have redundancy, you have connecting parallel series, whatever is necessary for the application. And the same architecture can be used, are used also for components inside, not only for the load in this case. You have to consider also the beta factor. Beta factor means that the device, if you use two components from the same manufacturer, from the same batch, with the same code, they probably would fail at the same time. So they will reduce your safety. So the most important thing is, of course, change the typology of device if you want to have in using redundancy, because you can, otherwise you lower your safety for your application. Basic component failure rate give a final result. The SF table also apply to components, better components and better results. Also, characteristic of relay like gold plating contact, sealed relay, force contact, multiple single internal contact are really it's important for your safety relays. And also, as we say, we talk about failures, lambda safe and lambda dangerous. So the dangerous failure for each component are really most relevant, because you can have dangerous safe, so safe failure that are failure, but they are safe. They do not bring the device to, say, unwanted or the dangerous situation. And the dangerous failure are the most critical, because you can have dangerous, but they bring to safe situations as well. But you can, it's dangerous, but you can detect this dangerous failure. This is the most important, because they bring to a situation you see immediately that there is a dangerous situation. But other danger that you cannot detect, that those are the very most critical. And for, as we say, for each component you have to evaluate the both dangerous detected and dangerous undetected failure, both safe and of course dangerous. Safe and dangerous failure, what is the difference?
We are some minutes after 12.
Yeah, but we can continue. I hope people stay here, because this is very important. No, I will say that this is another explanation. You have the total failure are safe and dangerous. The total safe are safe detected, safe undetected. Total danger, danger detected, danger undetected. So the situation here. Just an example. 4 to 20 milliamp signal. So you have situation with lower than 4 milliamps and higher than 20 milliamps. So lower than 4 milliamps, you can have a dangerous, but you detect because you see that is lower than 4 milliamps. You can have safe, but you detect as well because they are lower than 4 milliamps. The same thing for higher than 20 milliamps. So you have dangerous and safe, but both you detect because you are over the range. The most critical situation is in the range. So if you have a big, say, variation, it can be, of course, you can, of course, so in situation, sorry, in situation you have only modification, maybe a little variation, 0.8 milliamps, like in this case, you have a situation where you undetect, but it's safe because it's not changing too much, okay, the values. The most critical situation, you have a big variation, but as long as in the range 4 to 20 milliamps for you is okay, you don't have any problem. But probably you have a bigger mistake on your measuring, and maybe that it can be dangerous, really undetected. So this is the situation. Situation, yeah, it's for you probably, Maurizio, right?
Voice and radius classification. Yes, this is the one slide with the difference between diagnostic function is not interfering with the SIL safety function. We are speaking about two different things because diagnostics, as you can see, is SIL2 certified, while the barrier and the safety function are SIL3 certified. They are not linked, so you can see that are different, and so there is no an interconnection on something that can influence the difference. So you can see one is SIL2 and the other is SIL3. The diagnostic SIL2 does not interfere to the SIL3 safety function.
Okay. We are to the end. Thank you, Maurizio. So
You,
if you
Andrea,
wanna launch this poll, maybe
Next
this your comments will help us in improve our communication, and maybe if you are in need of having some specific webinar, something, maybe we can of course think by the time to do that. Of course, it's anonymous. You can write whatever you like. If it was not good for you, you can write, please, write down. We are not perfect. We are just experienced persons in the market, nothing else.
Yeah.
We are not R&D people. Okay.
Likely.
So maybe next time we will have a speaker, one R&D guy that will explain in detail everything about the product. But I don't know if it's is the one you would like to hear, because maybe
but anyway, any kind of suggestion is well accepted, and we thank
okay, thank you very much. We can stop here.
Can stop.
And
thank you.
just a last question, if you will, this webinar is on our, will be, of course, other webinar will be in our website. You can get also the link in the information. The past webinars on our YouTube channel, as well as this one. And that's all. This is our, of course, last contact. Of course, our name, emails, and face. If you want to get in touch with us later on, please do it. And thank you, Maurizio. Thank you all.
Andrea. Thank you to you all. Thank you very much. Have a nice day. Bye-bye. See you next time.
Bye-bye.